Hi everyone, myself Dr. E. Sridevi, Professor, Department of Electronics and Communication Engineering. In this video lecture, we can able to learn what is Coulombs Law and its applications of Coulombs Law. On completion of this video, the learners can able to understand the basis about Coulombs Law. So first, objectives of Coulombs Law. That is, it is for understanding the concept of electric charge and electrostatic force. Then it is also used to state and explain Coulombs Law. And also in this video lecture, it is for representing the Coulombs Law mathematically and vectorially, and explain the principle of superposition, and also apply the law to multiple charge systems. First one is the introduction to electric charge. Electric charge is a fundamental property of matter responsible for electric forces. There are two types of charges. One is positive and the another one is negative. And like charges repel and unlike charges or attract each other. This one already we know. So according to Coulomb, the definition of that law is, the electrostatic forces existed between two stationary point charges. So this force is directly proportional to the product of charges and inversely proportional to the square of the distance between them. First, the mathematical expression of Coulombs law, that is force existing between these two charges, let it be Q1 and Q2. So F is equal to K into Q1 Q2 divided by R square. Here F is known as electrostatic force, which is represented in terms of the unit as Newton, and Q1 and Q2 are the magnitudes of charges. It is represented in the unit which is called as coulombs. And here R is the distance between the charges, two charges, and it is represented in the unit which is called as meters. And K is equal to 1 by 4 pi epsilon naught. The value of K is constant and it is given as 9 into 10 power 9 Newton meter square divided by Coulomb square. And this can be written as the two point charges Q1 and Q2 are represented by the displacement motion, and the force is given as F12. F12 is equal to 1 by 4 pi epsilon naught into Q1 Q2 divided by R square, and R12 is the unit vector between 1 and 2, and F12 is the force on charge Q2 due to the charge Q1, and epsilon naught is the permittivity of free space, and R is the distance between the two charges. R12 is the unit vector directed from Q1 to Q2, and R12 is given as R12 is equal to R2 minus R1 divided by modulus R2 minus R1. And force acts along the line joining the charges. Force is repulsive if Q1 Q2 is greater than 0, that is called as like charges, and force is attractive if Q1 Q2 is less than 0, that is called as unlike charges. The derivation of vector form. Considering two charges Q1 and Q2 with positions R1 and R2. R12 is equal to R2 minus R1, and the unit vector A12 is equal to R12 divided by modulus R12. F12 is given by substituting these values 1 by 4 pi epsilon naught into Q1 Q2 divided by R12 squares into A12, and we know that A12 is the unit vector. Direction of forces, that is if both charges are positive or both are negative, they are called as repulsive force. If one charge is positive and the another one is negative, it is called as attractive force. So F21 equal to F minus F12, that is according to Newton's third law. Principle of superposition, the net electrostatic force on the charge is the vector sum of individual forces exerted by all other charges, that is F is equal to summation Fi, that is 1 by 4 pi epsilon naught into summation Q into Qi, that is R minus Ri divided by R minus Ri the whole cube. So conditions for applicity, that is applicable conditions is the charges must be stationary, that is static. Distance between the charges should be large compared to the dimension. Medium between the charges should be uniform and isotropic. For vacuum, the epsilon naught value is equal to 8.854 into 10 power minus 12 F bar m. So we have one problem based upon this. Here it is given as two charges plus 2 microcoulombs and Q2 is equal to minus 3 microcoulombs separated by the distance r is equal to given, and you are asked to find the force between them. And according to Coulombs law, we know that F equal to K into Q1 Q2 divided by R square. Q1 is given, Q2 is also given, and R is also given. Substituting these values and calculating F, it is noted as F is equal to 2.16 into 10 power 1 Newton, that is 21.6 Newton. That is F is calculated as attractive since charges are opposite. And graphical representation, we can represent this one by the lines joining between these two charges. Like charges show repulsion, unlike charges show attraction. Field lines indicates the direction between electric field and force. So combining all this, Coulombs law defines the electrostatic force between two charges. The forces varies directly with charge and inversely with the square of distance, and direction depends on the nature of charges. Principle of superposition allows extension to multiple charges. Hope you all understand this session. Thank you.